This is MathGuide.com. My name is Mark Karadimos. Today we're going to talk about central angles and their respective arcs. Okay, let's draw a picture. Well, let's take a look at this diagram and let's analyze it a little bit. We notice that we've got a chord here, and I'm going to assume that this chord goes through the center of the circle. As a matter of fact, I'm going to say that this is a diameter. Okay, if this is a diameter of a circle, we know that there actually is a line that does travel through it, and like all lines we know in geometry, lines have an angle of 180 degrees. Okay, so a line is actually a 180 degree angle. Okay, well, we also know that if we've got a circle is 360 degrees, right? All the way around a circle is 360. And we know that if we draw a diameter of a circle, the diameter cuts the circle into two equal portions. So that means that this arc is equal to the other arc below it. And that means that these two arcs, if they equal 360, each one of those arcs is equal to 180 degrees. So this too must be a 180 degree arc. So we could see that this angle here towards the middle of the circle, called the central angle, is equal to the opposite arc that it cuts into the circle. Okay, well, I've been throwing around the term central angle. We should talk about what a central angle is. A central angle is an angle that has its vertex at the center of the circle, and then the two sides of the angle are actually radii. The radii of the circle. Okay, let's take a look at another diagram. Here we have another diagram, and I'm going to say that these two chords are actually diameters of this circle, and they're special diameters. The diameters are actually perpendicular, so they make a right angle. So if these two diameters are perpendicular, then we know that this makes a 90 degree angle. Okay, so that means that we've got vertical angles. This is 90 degrees, and because this is a line, that has to be 90 degrees. In other words, they're all right angles. Okay, so we know they're all right angles. Every angle here at the center, a bunch of central angles. Alright, well, we'd like to figure out what is the angle here. What are these angles? I should say not angles, the measure of the arc, of all these four measures of the arc. Well, if you take a circle and you divide it into four equal sections, because I do have equal central angles, then the arcs also have to be equal. So that means that if I take 360 degrees and I divide it into four equal arcs, then definitely I'm going to get, let's see, 360 divided by 4, I'm going to get 90 degrees. So each one of these arcs is 90 degrees. So this is, of course, tells us that yes, indeed, that these central angles are equal to the measure of the arcs that they are opposite. Okay, I'm just going to keep rolling through, and we're going to do more problems, and actually we're going to get into some problems. We're actually going to solve some things now that we have this newfound knowledge that central angles and their arcs are equal. Okay, on to our next example. Here is a problem where we have a known angle, known central angle. I know that two arcs are congruent to each other by these little tick marks. That's what they mean. And I'm trying to find this unknown central angle. Okay, well, first of all, if I know that these arcs are equal, then I could use that information to find this opposite arc. Okay, what does that mean? Well, if this is 130 degrees, the central angle, then the arc is 130 degrees. If this arc is 130, then this arc, which is congruent to it, is also 130. I know that all these arcs together have to add up to be 360 degrees. So I know that 130 plus 130 plus some unknown angle, which I'm going to call y, has got to be equal to 360. Okay, so far I've got 260 plus y is equal to 360. I'm going to subtract 260 from both sides, and I'm going to get 100 degrees. Okay, so that means that this arc right here has to be 100 degrees. Since we know that arcs and central angles are equal, I know that x also has to be 100 degrees. And there's my answer. Okay, on to the next problem. In this diagram, we have a diameter. So this diameter, of course, splits the circle into two equal halves. Alright, another piece of information here is I've got two congruent arcs, so that I know that if this is 20 degree arc, then this is a 20 degree arc also. Okay, some good information there. I do know that all of these arcs together have to equal 360 degrees. And more importantly, if you remember, the diameter cuts the circle into two equal halves. Also, the diameter cuts the circle into a 180 degree arc. So I know that this gigantic arc is 180. So what's this piece? Well, this piece has got to be 160. Because from this point, arced through here is 160, and then 60 plus 20 makes 180, which is half the circle. Likewise, for the other reason, I know that if this is 20 degree arc, the rest has to complete 180, so this has to be a 160 degree arc also. And if the arc is 160, then I know that its central angle is 160 also, so x has to be 160. Alright, here's our final problem, and this one's going to be more difficult. The objective for this problem is to find a large arc, and what we're going to do is find the measure of arc BDE. Okay, so before we get to the arc, let's find a lot of smaller arcs. Okay, again, I've got this diameter, so the diameter cuts the circle into 180 degrees. So if this is a 125, well then the arc is 125. And if I have 180 degrees, let's see, 180 take away 125 is 55. So this has to be a 55 degree arc. And likewise, of course, it's a 55 degree central angle, because central angles and arcs are congruent. Okay, I have another diameter, and of course that makes 180 degrees also. So likewise, for the same mathematics, this has to be a 55 degree arc. So this has to be a 55 degree angle. Alright, so I also know that if this is half the circle due to the diameter, then all of those arcs have to be equal to 180 degrees. If this is 80, the arc's 80. So all I am missing now is this angle and its respective arc. Well, let's see, 80 plus 55, let's see, 80 plus 55 is equal to 135. So 135 away from, well actually 135 is what I want to subtract from 180. That'll tell me what's left over here. So what do I have? I've got 55 again. Oh, 45, sorry. 45 that time. Okay, so I know now that this has got to be a 45 degree arc. And of course the central angle's got to be 45. Alright, so I found a lot of central angles and arcs. I found them all, as a matter of fact. Now I could find the measure of arc BDE. So arc BDE is BDE. So now I'm not going to go BE, which is a minor arc. I want to go the large arc, which of course is greater than 180. That's why you have to use 3 letters for it, BDE. So what I'm going to do then is add up all the arcs from B through D to E. So that means I'm going to do 125, I've got 55, and I've got 45. So if I add up all of those, I'm going to get the total measure of that arc. So let's see, that's 15. That should be 12. Let's see, 9, 10, 11, 12. And I get 225. Okay, so the measure of arc BD to E, that gigantic arc, is 225 degrees. Okay, so you've seen several examples that should help you understand central angles and their respective arcs. So go back to mathguide.com, check out our instructional videos, interactive quizzes, and text-based lessons. Take care.